Okay, so let's take a look at some cancellation properties. So here I have a sine of sine inverse of x just equals x. That's only when negative 1 is less or equal to x, less or equal to 1. I have sine inverse of sine of x equals x for negative pi over 2 to pi over 2. Cosine of x, or cosine of cosine inverse of x equals x between negative 1 and 1. And cosine inverse of cosine of x equals x for 0 to pi. Now, the easy way to think about this is think about it as like I'm doing something and then undoing it, or I'm undoing something and then doing it. And a lot of times if you do that, you get back to the original spot. Now the key thing is making sure that that x value satisfies one of these things. Otherwise you do have to do a little bit of work. So let's take a look at some examples. So let me move this over a little bit so you can see. So suppose I have sine inverse of sine of pi over 3. So that's this one right here, right? So I have sine inverse of sine of pi over 3. Well, pi over 3 is between negative pi over 2 and pi over 2. It's in between these two, like negative pi over 2 is over here, pi over 2 is right here, and pi over 3 is inside. So therefore, this answer is just simply pi over 3. And the story, that's as simple as it gets, okay? So we have that. Now, suppose I have this one, sine inverse of sine of 2 pi over 3. Now, 2 pi over 3 is not between these two, right? So this is quadrant 4, going backwards to quadrant 1. 2 pi over 3 is not in that. So the first thing you have to do is you have to first calculate what sine of 2 pi over 3 is. So this is equal to sine inverse of whatever we find sine of 2 pi over 3 to be. Well, you can always look at your unit circle and remember what happens on your unit circle. And if we have 2 pi over 3, right, here's 1 pi over 3, here's 2 pi over 3. We get that special point, okay, right here, which is negative 1/2, comma, root 3 over 2. Sine is the y value, so I know that thing right here is root 3 over 2. So then I'm looking for now sine inverse of that number. So sine inverse, we only talk about it in the interval negative pi over 2 to pi over 2. So erase all this. Imagine we're just staring at this now, and the question is, for what value is sine of something equal to root 3 over 2 only between negative pi over 2 and pi over 2? Well, when does that happen? Well, the y value is root 3 over 2 right here, okay, and that happens at pi over 3. So this answer here is pi over 3. Now again, you have to do more work on this one because this number was not between negative pi over 2 and pi over 2. Okay? Alright, so now let's go over to here. We're going to do cosine inverse of cosine of 2 pi over 3. Well, there's 2 pi over 3 right here, cosine of 2 pi over 3. Cosine of what? Is 2 pi over 3 between 0 and pi? Yeah, 2/3 of pi is between 0 and 1 full pi. So we know that this answer is just going to be 2 pi over 3, right? End of story, done there. But now we have a different one. We have cosine inverse of cosine of 5 pi over 3. 5 pi over 3 is not between 0 and pi. It's not in quadrant 1 or 2. Recall that 5 pi over 3 puts me, it's a little tough to see there. Move it a little bit over here. 5 pi over 3 puts me in quadrant 4. Right there, okay, so this is a t value, a length of 5 pi over 3, okay, and the value here is negative 1/2, comma, root 3 over 2, okay, good. So that's where we're at right now. So I know I can't just simply use my cancellation properties, so what I'm going to do is then realize that this is equal to cosine inverse of, what is the x-coordinate here? Well, the x-coordinate, excuse me, positive 1/2, negative root 3 over 2, I wrote that wrong. Positive 1/2. What's the x-coordinate here? Well, the x-coordinate right there is 1/2, so I want cosine inverse of 1/2. So if I want cosine inverse of 1/2, well, what do? Well, I find that cosine, I'm looking for the cosine of some number that equals 1/2. Now, again, in cosine, we only want to talk about it between, to make sure it's 1 to 1, between 0 and pi. So for what value what value can I put in here so that cosine of it equals 1/2? The x coordinate equals 1/2. Well, that turns out to be pi over 3, right? Pi over 3. So this is pi over 3, hence this is pi over 3. Okay? Good. Okay, so last thing we want to talk about this section is the inverse tangent function. The inverse tangent function is the function tan inverse with the domain negative infinity to infinity and range negative pi over 2 to pi over 2. And it's defined by the rule tan inverse of x equals y, if and only if tangent of y equals x. And of course it's got cancellation properties similar to what sine and cosine had. Tan of tan inverse of x equals x if x is any real number, and tan inverse of tangent of x equals x if x is between negative pi over 2 and pi over 2. So the graph of tangent, as we recall, it's got these asymptotes here that we approach. It's bounded there, left and right that way, and we've got this tangent function, and we copy and paste this for every period of pi after pi over 2, so 3 pi over 2, pi over, and so forth. And so if we look at that, right, this is the x coordinate, y coordinate 0, 0, so flip the y, flip the x, and 0, 0. Good, and as I approach here pi over 2, as I approach pi over 2, I get closer and closer to infinity, which means as I get closer and closer to infinity, I should approach pi over 2, just going the other way, so it should look something like this. And over here, as I get close to negative pi over 2, I go to negative infinity, so as I get close to negative infinity, I'm going to approach negative pi over 2. So that's a graph for tangent inverse. Okay?